So, welcome back to the course on green manufacturing systems, where we are trying to attain the sustainable objective using green manufacturing systems. So, we need to understand what are manufacturing systems. So, this lecture would specifically talk about the manufacturing system. Dr. Deepu Philip has already given you an introduction, what is a production system, some major elements of production systems. So, I will like to put some more details on the manufacturing system constituents. So, what is the manufacturing system consisted of, and how we work on it. So, the contents would go like this. First, we will talk about the facility level process chains, then we have unit manufacturing processes, then we have spatial and temporal boundaries in a manufacturing system. This is all with respect to manufacturing system. So, we are doing this because finally, we will take you to the manufacturing science lab, where we will work on unit manufacturing systems, and those unit manufacturing systems would be used to perform the process chains, and that will then be considered to be making a full facility. So, let us start from the facility level. Facility is nothing but it is a factory. If I have a factory here, factory, or I can call it as an enterprise. So, we are more concerned with the word factory here. A factory is something that that has some inputs, like some raw material is there and some processing is done, and finally we get the finished goods, like as we did in life cycle assessment. The central part, the stage 2, where we had work in progress stage and we had work in progress inventory over there. So, that was a factory, that was a manufacturing system in which manufacturing happens. So, at facility level, what type of considerations are to be kept in mind while designing the facility for sustainability, like for or obtaining a green facility? So, before talking about that, I like to tell you about the certain kinds of plant layouts. How we will discuss, Dr. Deepu Philip will discuss that in detail. In factory, we can have a few kinds of layouts. One layout can be process layout, we can have product layout, we can have combination layout, and we can have fixed position layout. A process layout is when different sections are there in a factory which are doing only one process. For instance, we can have one section for drilling, one section for turning, one section for maybe assembly. So, one section is completely dedicated to one kind of process. So, what happens in process systems when material comes? For instance, if there are certain steps, the sequence is first milling, then drilling, then grinding, then some inspection has to happen to the material. So, it will go to the milling section first, then it will go to the drilling section, then it will go to the grinding section, and so on. In this way, the material will move. Next is product layout. When there is mass production, the product layout is more used. Product layout is based on the sequence of the product, sequence of the operations which are going to happen on the product. The machines are kept in series. So, in this case, a battery of activities are placed in series. For instance, like I said, the machine first, this was milling, drilling, grinding and inspection, that will be kept in, that will be one process only. So, this kind of, this is in, that will be one for one product only, and this kind of flow, the product flow, can also be called as flow line or process chain. Next, we can have the combination kind of layout, in which we have different sections which are dedicated to one specific process, and also we can have different processes. We can have a combination of these two to save time. So, next is fixed position layout. In fixed position layout, what we have for the very bulky products like manufacturing of ships, manufacturing of aircrafts. We cannot move aircrafts on conveyors on the overhung cranes. So what happens, the aircraft or ship is kept at one place, and the materials, other raw materials or the other components are brought at one place, brought at that place to assemble or to do some processing over there. So these are different kinds of layout. So we are more concerned about the flow line and process chain here. So at facility level, facility can have any kind of layout, any kind of these layouts. So at facility level, the plant or the building in this case, as I talked about the energy consumption, while the construction of a facility, while construction of building, there is a term known as BLCC, building life cycle costing, and also a similar term is building life cycle assessment. So if we consider the embodied energy in building, if I say embodied energy in building, so there can be direct embodied energy, there can be indirect embodied energy, there can be recurring embodied energy. Direct and indirect are considered. We are more concerned about the recurring. Recurring is the regular. Like how much energy would be used while we do maintenance and repair, while we'll run the ventilating systems, air conditioning systems, while for instance this is a factory, this is a mechanical factory which has some boiler, let me say. So what is the energy that is consumed, or what is the water conservation that happens to use boilers? So I can put it here. So we are more concerned about recurring embodied energy. So this implies heating, ventilating systems, HVAC systems, then we have ventilation, then we have boilers, then we have the method of lighting, so as to minimize the glare that can happen with the workers. See, we are working in sustainability, and sustainability has three major aspects: social, economic and environmental. So when we are talking about the economic and environmental, we are just talking about the cost and the waste and energy consumption. When we talk about the social aspects, what does this factory, this design has impact on the short term impact on the workers, and the long term impact on the people who live around there in this in that vicinity. So the glare, the lighting systems are important here. So how the lighting system are to be designed? What is the energy that is consumed? Can we use the natural lighting, or can we have some natural, or can we make a design in a way that natural ventilation happens? So all those things are important at facility level while considering green manufacturing system. So next is, I am talking about layout. The layout, these are the layout types. The layout has to be designed in such a way that we have minimum material movement, and we should have the appropriate pathways for workers. That is, we have the span between machines. See, machines are not kept so close that the workers started getting intermingling with each other. And also they are not to be kept so far that the material movement takes more time. So it occupies more space. So there is a specific span. We have to optimize the span between machines. The machine 1, machine 2, machine 3, what is to be the distance between these, depending upon the type of operation that is happening, depending upon the size of the machine, depending upon the number of workers who are to work on that, and all those things. So the span between machines. This is appropriate pathways, it is all covering that. So, this is the facility level. Next comes the process chains. So, I have chosen the flow line or process chain from the layouts. This is also known as flow line. Flow line is nothing, we have the series of processes here in one line and the material is moving in this direction. We have input here and output here. This is known as a flow line. So, the input here could be energy, water and consumables, and outputs are finished goods and waste. This is a unit manufacturing process. This we will discuss further here in the next step. We need to consider the material handling. Material handling here, the span between machines, and also the flow line has one drawback, because this is a series connection. So, if process 2 fails, the whole system comes to standstill. So, this is called the breakdown. So, what happens, the material, the processing that is happening in on process 1, that has to pass through process 2 to reach process 3. So, we need to have the alternative systems here as well. Alternatives, or we should be careful while designing the layout here, that we can also have some parallel processes. So, the green considerations here could be like we have line balancing. We divide the workload to the worker in a way that all the workers are occupied. We can use that concept in energy balancing as well. The power, that is energy that is supplied, which machine is working at which point of time, what is the peak energy one machine using, and at that point, and what is the other machine. We can synchronize in a way that the overall energy consumption in this line is minimum. So, we will work on this. This will cover in the next part in the connected course, but in this specific course, we will work on the unit manufacturing process, and we will make a process chain from that, and we will make a facility from that. So, the line balancing or the energy balancing we will also do, but in the next course. So, next we have is unit manufacturing process, which is the basic element. This is unit process. So, it can also have the inputs and outputs in the same way. However, these inputs are specific to the single process only. Unit process means a single process, maybe lathe machine, maybe milling machine, maybe drilling machine, maybe some electric discharge machine, EDM. So, what we are going to do in the experimentation, we are going to conduct the experiments, the live experiments on this unit manufacturing process. We will optimize the parameters. The parameters may be, for instance, for milling. The parameters is the speed of cutting, the feed, the depth of cut. So, these 3 parameters can be optimized with respect to the energy consumption, with respect to the quality of the product, energy consumption. For instance, the force that is consumed in doing machining can represent the energy. And I would say then second point is energy, after energy waste. Waste is, for instance, the cutting fluid is used. We can think of replacing cutting fluid with some biodegradable fluid. We can think of minimizing the use of cutting fluid and all those things. So these would be the responses, the energy waste. Input parameters would be feed, speed, depth of cut. Responses may be the pollution, waste produced, like I just said. So, and energy and the quality. For quality, we can consider surface roughness for that. So I can draw some. So I can give a quick glance on how the various graphics are obtained, various data is obtained. We have the input parameter here, that is input parameter may be speed, feed, depth of cut, any one of these, not all these three in one diagram here. So we can have some output parameter. We can have output parameter like energy. So how the energy, it might show some transient behavior like this one. Let me say like this one. Let me say I did it for 1, 2, 3, 4 and 5 different. For one it is this one, for second this, for third it is this, for fourth it is this, for fifth it is this. So these are the values obtained. We can see the minimum energy is in this case, case 1. So I have cases here, case. So I have cases here, case 1, 2, 3, 4 and 5. So I have minimum energy in case 1, or maybe I can have minimum energy some in some different cases we can also obtain. Also we can have the other parameters like this was energy. I can have surface roughness or some quality parameter. Quality parameter may be surface roughness, and surface roughness might also show some different kind of behavior for the different cases 1, 2, 3, 4 and 5. Surface roughness also has to be minimum. So let me say the minimum value is here. So we need to select this value here, this setting here and this setting here, and we need to optimize it in a way that combining these two different settings, what would be the best possible solution, what would the best possible setting of the machine to have the green machining. Green machining here we can give some weight to energy, some weight to roughness, and we can even give equivalent weights like we did in qualitative life cycle assessment. So like we can just trade off between these two the way we will like to do. So then waste can also be one of the factor. So we can consider waste here, and again the same parameters 1, 2, 3, 4 and 5, and how the waste is produced, like how much cutting fluid. This is for one unit process. We can obtain this kind of data for different unit processes individually. However, we can also conduct an experiment by putting all these machines in a line and then seeing what is the energy consumption in one line when we change the settings. But that would be a little complex. That can also be done. We can use any approach we like. But the thing is that ultimate aim is to minimize the overall energy in a facility. So while facility designing, we are considering the embodied energy. We specifically the direct and indirect energies here. And while working, we are also considering the recurring embodied energy, and in process we are taking the unit processes together, and in a single unit process we are considering the input and output, and we are just looking at the parameters here. Next, I like to discuss the spatial and temporal boundaries of a manufacturing system, like what kinds of decisions are to be made and which positions, what are the temporal scales and what are the times. So how we can do this? So this I have, I'll reproduce a diagram which is taken from Vijay Raghavan, who was a PhD scholar with Dr. Dornfeld, and they published this work in 2010. Dr. Dornfeld, he was an icon in green manufacturing. So he's now late, Dr. Dornfeld. He passed away in 2017. He had done a significant research in green manufacturing. So his blogspot, you can read that as well. Green manufacturing blogspot, that is all available online. So they came up with this temporal and spatial arrangement or the setup in which we have the time here from the milliseconds to some weeks. So in between we can have milliseconds to seconds, then hours, then days, and on this side we have tool chip interface. So when I was talking about unit manufacturing process here, the tool chip interface, this all surface roughness, energy, this is the tool chip interface. When tool is connected to the, well, tool is in contact with the workpiece, the cutting is happening in milling. This is tool, this is workpiece, cutting is happening. What is the energy consumed? So this kind of pair, that is the process control. You can put here, this is actually process control. So the time for the process control is from a few milli or microseconds to a few seconds. So because that is a very small time when machining happens. So the next point here is machine in a broader level. If I combine few unit processes, few machines, machine is actually a unit manufacturing process here. This is a unit process. When I combine a few unit processes, it makes a process chain. When I combine a few process chains, it makes what? A facility. So when, as I was talking about the industrial parks, I can even extend this diagram. When I was talking about industrial parks, there are certain facilities which are arranged, a number of facilities which can have collaboration between them, which can have some partnerships, and they are all working. So in that case, what happens? Raw material or some processed material, some components, some ancillary units are there which are supplying material to my facility here, and my facility is also producing something. It is supplying it to somebody else who does assembly, who does packaging. Those things happens. So this all connection between facilities is known as supply chain. You heard of the term supply chain management. So this is supply chain. So what do you think? We have put tool chip, machine, process chain, facility, and supply chain. What would be the time to take decisions for supply chain, the policy matters? It would be, would it be few milliseconds or microseconds or seconds? No, it would be a few weeks, a few months to decide, to make the decision that who would be the vendors, what are the materials coming in, what is the economic order quantity, the supply chain decisions. That would be few weeks on this diagram, and at facility level decisions in a shorter period of time. The process chain much shorter than that, and machine level is just above the tool chip interface. So we can have this kind of Venn diagram here, and I can put it as micro planning. Micro planning that starts from a few seconds maybe to few minutes or to maybe maximum 1 hour. So it is the machine setting that is happening. So you can see there is a little overlap here between micro planning and process control, because micro planning decisions are to be disseminated to process control here. So what happens after micro planning? Micro planning actually it happens before micro planning. Micro planning is an result of what? A macro planning. A big plan is made. After that, the small elements are picked from that plan, and micro planning happens. So what is the bigger thing here? That is the macro planning. So this is macro planning, and we have some overlap here as well. So who takes the decision? The process control decisions are taken by the machinist. These are taken by the supervisor. So these macro planning decisions, who take these decisions? These might be taken by the shop manager. Here shop means one specific room, one specific section in the building, the machine shop, the drilling machine shop. That manager might take the macro planning decisions, that what kind of products, what kind of and how many number of units would be given to which machine. This type of decision this person can take. So before macro planning, what leads to macro planning? The next kind here is at facility level what happens? Production planning. Production planning, overall production planning, that happens for a few days, for these many number of days. You see we have days here. What would be the number of units those are to be produced? Also we can see we have some overlap here as well. And who takes this decision? The production planning for a facility. So these decisions are taken by the person who is in charge of that facility, who is of the specific facility, or maybe the specific, if I am talking about the before macro planning, we have the production planning here. I can put the production manager. He takes this decision. And in the top, what we have is supply chain, and these decisions might be planned for a few weeks. And what we have here is supply chain management. The supply chain management, who takes the decisions for the supply chain? It is the upper level of management. It is the maybe the CEO. I will put the management. The supply chain management. See, we have put the management here because supply chain management is not only the material flow. We need to consider the funds. We need to see the material requirement plannings. We need to see the master production schedules. Those inputs are given by the production manager. So the management, the team, the full team takes the decision, not the one person in general. So this is the spatial and temporal boundaries for a production system. So I'll like to stop here, and Dr. Deepafuli will continue with some more information regarding the facilities, regarding the types of layouts, regarding the types of elements in manufacturing systems. So before stopping, I have a task for you people. So I can understand that all of you cannot have an access to the factory or some workshop. So I can give you some task that you can do in your hostels or in your home only. Like if you have some access to some workshop, try to visit that workshop. If not, then try to see the room in which you stay, or in the hostel which you stay, or in your study room, and try to see this building life cycle assessment. However, we have not discussed building life cycle assessment in detail, but you can just see that what you can do to improve the ventilating system, to improve the lighting, and to minimize mobility. You can pick a paper and a pen, just draw the kind of layout you have in your room. You have table, you have chair, where are your clothes kept, where are your books kept, and what is the mobility, what kind of movements you do in the day, and what is your frequency of movement. So what you can do to minimize this mobility. So this is a broad task. You can choose any kind of facility you like. So with this, I like to stop here, and I'll meet you in the next lecture. We'll discuss more on green manufacturing systems. Thank you.